See, today we are going to implement OSPF between PE and CE, provider edge and customer edge, and this time I'll be configuring this MPLS only for customer Yahoo. And you can see that for customer Yahoo, in between PE1 and CE1, which is London site, I'm using OSPF 1 area 1, OSPF 100 actually, not 1, OSPF 100 and area 1, and then at the end of PE2, which is this router, right? In between this PE2 and this Paris site, Yahoo CE2, also I'll be configuring OSPF 100 area 1. Any problem? Any problem in it? Sure? Good. Or apart from that, okay, first of all let me configure same area, and then after I can also change these areas as well, right? I can use area 1, area 2, something like that. Fine. So I hope that you people are getting my point over here, right? Like I will be using and I will be doing this configuration only for customer Yahoo. I will not do any configuration for customer Microsoft. Fine. So today we are going to learn that how to implement OSPF in between PE and CE. Because the behavior of OSPF is a bit different from other routing protocols such as RAP, SGRP, and of course BGP as well. There are some differences, right? That's why I am just going through this dedicated topic, right? So we have to focus on OSPF while we are configuring it in between PE and CE. Right, so this time I have configured, as you know, that provider network, so I don't need to do anything else at the end of provider. Yes, whenever I'll connect any customer to provider, then I have to do some configuration over there, right? So let me have the console of Yahoo CE1 now, and let me configure it as well. I have to configure it, right? So on Yahoo CE1 I'm having some loopbacks in the range of 20 networks. Then on to FA0/0, its IP address is going to be now 3./24. Router of OSPF 100, router ID is going to be, let's say, is what? What do you want to configure here? Let's configure its router ID as 100.1.1.1. Any problem? Or do one thing, 100.100.1, and then after say, because on all interfaces I'll be using area 1. So IP OSPF interface brief, OSPF must be enabled on all interfaces of this device now. Interface loopback 1. Let me configure its network type is what? Even on to FA0/0 as well, I can configure. Then move on PE1. On to PE1, the very first thing that you have to do is you have to create VRF with the name. Let's say RT is what? Route target. For exporting I'll be using route target. For importing I'll be using. Accordingly, I have to do configuration on far end. Then after, go to FA0/1, say IP VRF forwarding, name is, IP address is going to be now. Any problem? Then say router OSPF 100 VRF, tell me, Yahoo. Router ID is 100.100.100.2. Over there I configured 1. Then say network 180.168.3. area, go to FA0 by 1, say IP/OSPF 100 network type. Neighborship must come up now. See, it is showing me two neighbors now. One is on FA0 by 0, 0 by 1 actually, and one is on. But you see that this is within the provider network, and this neighbor is out from the provider network. Now if you check show IP route, you will not get anything coming from there like 20 is prefix. But if you say show IP route VRF, tell me. Right? Then after, you see all of them are coming on /24. If you check R1's database, this is PE1, right? Let me rename it. Show IP/OSPF database. See, database for process 100 is is different from the database of process, and by default prefixes can move from one process to another process. So that's why I told you in previous class that basically we were having these process IDs available in OSPF just because of VRFs, because those process IDs were integrated with. Now you can see that we are integrating these process IDs along with VRF. So basically now you don't need to see anything for VRF. If you see for this process ID, it will show you all about that VRF only. You don't need to specify VRF. Like in AZRP, if you want to see your neighbor, you have to specify your VRF name. But in OSPF, it's not necessary, because here you can specify your process ID in place of VRF name. You understand? Then after it, because we have done it now, we have to perform redistribution now over here, right? So that prefixes can move from OSPF back into BGP. So for doing that, say router BGP 100 address family, tell me IPv4 VRF name is. Say redistribute OSPF 100 VRF name is. That's fine. Now you can check VPN table of PE1. Show IP, BGP, VPN, V4 all. Enter. Check it out for VRF Yahoo. All of them are available in the VPN V4 table of PE1. Now we can move on. PE2. Create IP VRF name. It's not mandatory to use the same name, common name, right? It's not mandatory, you can use any name. Then say RD. It will be good to use same RD value. Then route target. For importing, it must be 3:2. And route target for exporting, I'll be using. And then after, do one thing, implement OSPF in between PE2 and this Yahoo customer S2 as well. So let's configure Yahoo customer S2 first. Loopback 1 and 20.1.6.1. Then 7.1, 8.1, 9.1. Finally, FA0 by 0 IP address must be Then after it, router OSPF, and it's like 100. Router ID 100.1 100.100. Let's say here for network area. Go to loopback IPv4 network type is what? Loopback 2, so that it will start to advertise them on 2/24 and on to FA0/0. Let's make it point to point as well. Move on P2. Go to FA0/1 IPVRF forwarding. Name is IP address should be come out, say router OSPF 100x and VRF. Tell me router ID dot. So I have allocated router ID on Yahoo C1 as 1, on PE1 as 2, on PE2 as 3, and on to C2 as 4. Then say network area. Go to FA0/1 IPv4 network is what? Point to point, and now neighborship must come up. See, show IPv4 name, show IP route VRF Yahoo. Check it out. Some prefixes are coming with the help of BGP, and some of them, I mean some are coming with the help of OSPF, because which are coming from site 1, I mean Yahoo site 1, Yahoo site London. Prefixes coming from London are learnt onto PE2 from BGP, whereas if prefixes are coming from site Paris, then they are coming with the help of OSPF onto PE2. Then we need to take prefixes from BGP into OSPF now, so you have to perform redistribution from BGP into OSPF. So say do one thing, router OSPF 100 VRF name is what? Yahoo. Say redistribute BGP 100 subnets, metric type is 1, tag or let's say 200. Any problem? Redistribution must be done successfully now, right? So now it must originate type 5 LSAs. It must originate type 5 LSAs, and then we must be able to see all of them onto Yahoo C2. You see, all of them must be available over here. So see, all of them are coming like 1, 2, 3, 4, 5. All of them have came into the routing table of Yahoo CE2. In same manner, we have to take these routes back. I mean, we have to take prefixes from this Paris site to, tell me, from this Paris site to London site. For doing that, onto R3 itself, so router BGP is what? Address family IPv4 VRF. Then say redistribute what? 100 VRF name is Yahoo itself. Now you can ask me then, sir, why are we integrating these VRFs? I mean, like why are we calling this VRF name along with OSPF process ID while we are redistributing this OSPF into BGP? See, the thing is like, as you know that one process ID, I mean like you can allocate your process ID to any VRF, so it is mandatory, it is I mean it's required to specify your VRF name along with process ID while you are redistributing from OSPF into BGP. In other routing protocols it was not required actually. Now you see, show IP BGP VPN v4 all, enter. So you must get them, and then you must receive them onto PE1. Show IP BGP VPN v4 all, enter. Check it out. So all of them are present over here as well. See, prefixes are coming from 3333, and then you can see show IP route VRF Yahoo. Check it out. So all of them are present over here as well. finally you have to redistribute this BG back into OSPF now onto PE1 as well. Router OSPF 100 VRF is what? So redistribute OSPF 100 VRF, sorry, redistribute BGP 100, right? Subnets. Matrix type is tag. I must get them onto Yahoo C1 now. Now you can try to communicate with, and source is your own loopback. Oh, that's why. Not on R3, actually on R2 as well. Router OSPF1, MPLS LDP, config. Onto R3 as well. Fine. Now then ping. So if you skip any single step, you see, right? So everything is fine now, but I don't know what you people are watching over here. You never asked me that we redistributed from BGP into OSPF, but prefixes are coming as inter area. However, they should have came here as external prefixes. It should have generate type 5 LSS. But if you check database table of Yahoo C1, type 3 LSA generated by PE1, because as I allocated this 100.100.100.100.2 on PE1. Why? Remember, for OSPF, if you are connected with MPLS backbone, if you are connected with MPLS network, VPN v4, that's called super backbone. Means that your MPLS domain is also known as super backbone for OSPF. Super backbone means that it counts it as area 0. It counts it as a area 0. Remember that for OSPF, MPLS domain will always be like super backbone, which is same as area 0. So remember, OSPF will always treat your VPN v4 as a super backbone, and even we can see that. I will show you onto PE1 itself. Guys, try to check it out now. See, on PE1 I configured show IP OSPF 100 for VRF Yahoo. Check it out. What is it showing you? And because it is saying that it is connected with super backbone, that is why, because we perform redistribution, so it has to be an ASBR, but along with that it is also showing you that it is also working as an ABR as well, because it is thinking that it is connected with super backbone, which is same as area 0. But again, that's fine that it is treating this MPLS VPN as a super backbone. That's fine. But why type 3, not type 5? It is generating type 3 LSAs, right? That's fine that it is treating this MPLS domain as a you understand, like super backbone area 0, but still you performed redistribution and it is working as an ASBR, but still it is not generating any type 5 LSA. It is generating only type 3 LSA. Why? In OSPF there is a technical term for MPLS which is known as domain ID, Once you will start to use MPLS, and then if you MPLS VPN, and then if you connect your OSPF to your MPLS VPN, then it will start to use domain ID. Domain ID will be calculated by your device automatically with the help of its process ID. As I am using process ID as 100, so see 0.0.0.100. Last digit is showing you your process ID. This is the domain ID type and value onto P1. Now move on P2 as well. Show IP OSPF 100. Check it out. Its domain ID should be same. It is also same, right? Now remember that whenever you redistribute your prefix from OSPF into VPN v4 address family of BGP, right? Try to understand, try to remember that whenever we redistribute OSPF into VPN v4 address family of BGP, then this domain ID will always get copied into your BGP updates. It will go as extended community. This domain ID of OSPF will go along with BGP updates as extended community. And whenever you will redistribute those prefixes back from BGP into OSPF, whenever you will redistribute those prefixes back from BGP into OSPF, then during redistribution OSPF will check that of course there should be some domain ID. If it receives domain ID with those prefixes, then it will compare that domain ID with its own domain ID. If both domain IDs are common, then your ASBR will generate type 3 LSA, not type 5. Then it will generate type 3 LSA, not type 5.
Process ID is different, it will...
If process IDs are different onto both PE routers for customer, are you getting my point or not? If process IDs are different for customer on each provider edge device, like here I'm using 100 and on another end if I start to use 200, then domain IDs will be different. So whenever PE1 will on PE1 you will redistribute OSPF back into BGP, it will copy its own domain ID onto those prefixes, right? Then whenever you will redistribute those prefixes from BGP back into OSPF onto PE2, then it will see that domain IDs are different, and in that case it will generate type 5 LSA. So this is happening due to domain ID. And to see that okay, that domain ID will always go along with BGP prefix, right? BGP update. So we can see that like onto P1. See, I'm on P1, right? So on P1 you redistributed OSPF back into VPN, right? So while you redistribute, during the redistribution from OSPF into VPN v4 onto PE1, your domain ID will get copied into BGP prefix, right? Domain ID will also get copied back. Copied into BGP updates, or you can say in VPN v4 entry. So see, show IP BGP VPN v4 VRF is what? Yahoo, and prefix was 20.1.0. Check it out. Check it out. This is your domain ID. Here it is represented in hexadecimal format. See, last value. It is represented in hexadecimal format. Where previously we saw that it was represented in IP v4 from. Especially its value was represented in IP v4 format. This is your domain ID. Type is same as over there, but last value has changed. See, now because it is available in BGP prefix, right? So it will be forwarded towards PE2. So if you move on PE2, even you can check it out here as well, like show IP, BGP, VPN v4, VRF, Yahoo. Check it out, it's coming. See, and when you will redistribute this BGP back into OSPF, now OSPF will compare its own domain ID with this domain ID. It will find that okay, it is same, and then it will generate type 3 LSA. It will generate type 3 LSA. That is why if you say show IP OSPF database, show IP OSPF 100 and then database, check it out, it is generating summary LSAs. You understand? Hello? Because if you check the domain ID, like this is the domain ID which is coming from there and generated by itself, is you can see that, you can see its own domain ID in this prefix, right? Because 20.1.6.0 is originated from P2 itself. Let me show you. And now compare their domain IDs. See, this is the domain ID of PE2 and this is the domain ID of PE1, because this prefix is coming from PE1 and this 20.1.6.0 is advertised by PE2. It's not it. Hey, you redistributed this 20.1.1.0 onto PE1, but you redistributed this 20.1.6.0 onto PE2 into BGP. Hello, 6 is coming from Paris. 1 is coming from London. So domain IDs are same. That is why it is generating type 3 LSA. If you change their domain IDs, now there are two methods to change these domain IDs. One, you can change their process IDs onto both ends. Like here, onto P1 you are using process 100, onto P2 you can use process 200. So their domain IDs will become different. Or you can also configure your domain ID manually. You can also configure your domain ID manually. I'll change it onto P1. Router of SPF 100 VRF, IP of SPF domain domain ID, and then anything like, what should I configure over here? 100.100.100 dot same as router ID, or you can say 1.1, different from router ID as well. But previously it was 0.0.0.100. Now it will get changed. Now it will get changed. And now you will see that both P routers, P1 as well as P2, they will start to generate type 5 LSS. Let me show you now. Show IP OSPF database. Show IP OSPF 100 and then database. What is that? In same manner, you can move on P2 as well. Show IP OSPF 100 and then database. See, still I'm using same process ID, but I have changed their domain IDs manually. Then you can move on Yahoo C1. Previously they were coming as inter area, but now they will come as E1 that we configured over there, and also they will be containing tag values. Onto Yahoo C2 as well, they will come as external prefixes now. So I hope that now you have understood the uses of domain ID in MPLS of OSPF. Shadib, this is the uses of domain ID. Fine. So in T-shoot, what can they ask you? They can give you the output of one router that okay, these prefixes must available over here as inter area or external. If they are coming as inter area and you know they were redistributed, it means that on both PE routers It's mandatory that they must have same domain ID. And if they are coming as external, then make sure that you are having different domain IDs onto both PE routers. So it will be depending on the given output. If prefixes are coming as inter area, same domain ID. If prefixes are coming as external prefixes, then different domain IDs. To configure different domain IDs, there are two methods: by using different process IDs, or modify a domain ID manually, statically. Have you understood it now completely? Sure. Hello, the uses of domain ID.
Sir,
Yes.
R1 पे process ID 100 और R2 पे भी process ID is supposed to 100, but हम manually domain ID change करके 100 करते हैं, तो फिर
Then again inter area, because whatever the domain ID, it will be depending on that only.
manually जो होगा वो
Of course. Understood? Any problem in it? Tell me. Sure. Great. Once again, I'll move back on PE1 and I'll configure same process ID. I mean domain ID, sorry. I'll remove it and it will pick default, right? Okay. Let it. Okay. Now, see, once again over here they will come as a type 3 RSA. See, it's not it. Now, there is a small problem in OSPF. See, there is a by default rule in OSPF that by default OSPF will not redistribute external prefixes into BGP. There is a by default rule that by default OSPF do not redistribute external prefixes into BGP. Now, just try to understand. Let's say this is PE1. This is what P2. We have taken two different customers, two different connections from two different service providers, CE1, and this is what CE2, and this is again customer router, right? So if you redistribute anything, let's say that OSPF is running in between P and C, and here also you will redistribute BGP into OSPF over here. Then here you will be redistributing OSPF back into BGP, but because they are coming as external prefixes, so by default they will not get redistributed back from OSPF into BGP by default, right? But if you are adding keywords like external and all, then definitely it can redistribute them into BGP again, right? but by default it will not do that. So if you are doing that mistake, it means you are doing it knowingly. It's not happening unknowingly if you are adding external keyword during redistribution, right? Otherwise by default there will not be any problem in the network, fine, there will not be any loop. But let's say that you are using same process, same domain IDs, so prefixes are going as inter area prefixes now into OSPF domain from MPLS VPN, because this is what MPLS. So they are going now as a inter area prefix, not as external prefixes. Like here we saw that prefixes are coming as inter area prefixes. So now it will give it to customer as 1, customer will give it to this on router, then it can give it to customer as 2, customer as 2 can give it to PE2, and on PE2, because we have already performed redistribution from OSPF back into BGP, so all those prefixes can get redistributed from OSPF back into. Are you getting my point or not? And there can be a routing loop. How to avoid it now? To avoid this problem, there is a rule, there is a bit in MPLS which is known as down bit, If you are redistributing BGP into OSPF, I mean prefixes from VPN into OSPF, and if they are going as inter area prefix, means that type 3 LSA, then in all type 3 LSAs it will add down bit. It will fix down bit onto all type 3 LSAs. And whenever, now once again onto PE2 you will redistribute this OSPF back into BGP, right? At that moment it will check that is this LSA or this route is having down bit. If that prefix is having down bit, then it will never redistribute, I mean OSPF will never redistribute all those prefixes from OSPF back into BGP, never ever. All those prefixes which are coming with downward bit will never get redistributed from OSPF back into BGP. Have you understood it or not? So basically for inter area prefixes we are having this rule. See, for external it won't do that by default, but for inter area, means for type 3 LSAs, we are having this down bit, and we can see that down bit right now on Yahoo CE1. All of them are coming as show IP route. You see inter area means type 3 LSA, show IP OSPF database summary, check it out. You understand it now? Have you understood it or not? So in this way there will not be any routing loop, or you can say in this way OSPF prevents MPLS domain, I mean prevents our network from routing loops. Have you understood it or not? Sure. Great. So in this way OSPF, I mean the behavior of OSPF, as I said, that it's a bit different from any other routing protocol like RIP, EICRP, BGP itself. Right? Then after it, after going through this domain ID and this downward bit, I mean all these loop prevention mechanism, now prefixes are coming as inter area, right? On both sides. Great. If this is my MPLS link and this is my primary link, as you can see over there, right? These are my primary links, MPLS links, right? But for redundancy purpose, I have taken one satellite link. Let's say I have taken one satellite link, and this is what? Backdoor link. You understand? This is what? Backdoor link. So here I'll be using IP address as 12.1 onto Yahoo C1, and onto Yahoo C2 I'll be using 12.2. Are you okay with it? Are you okay with it? And both both sites are using same area 1. So of course they will form neighborship, right? Because if you are using different areas, then it is not possible for them to form neighborship. So now on to Yahoo C1, I'm going on its interface FA0x1, and I will allocate its IP address as, and you will see that OSP will get enabled automatically because I have already used 00 command over here, right? And then say because this is like 12.1, and then after make it IPOSPF network type is what? In same manner I will move on Yahoo C2 onto its FA0x1. I will allocate its IP address as 12.2, but I have to configure its network type as neighborship must come up. Fine. This is my backdoor link. My traffic should not go via this backdoor link because this is really costlier than MPLS link. My primary link must be via MPLS. I mean my traffic should go via MPLS link only. Now let's move on Yahoo C1. Check its routing table. If you trace route from where it is going, why?
Shortest.
Tell me why. Intra area. Now here see, it is receiving prefixes from MPLS domain as inter area, whereas via backdoor link it is receiving them as a intra area. Now it doesn't matter that what is the cost on FA0x1, like IPOSPF cost is 65535, which is the highest one. It doesn't matter now because you cannot manipulate that path selection by modifying its AD value or cost. Swipe it out. See, it will start to show you the highest matrix. See, but still its best path is via backdoor link. You can trace route it once again. What to do now? That's a problem. That's a very big problem. Are you getting my point or not? Now you could say that, sir, let's do one thing, let's use different areas into both sides, right? But how will it be possible for them to form neighborship? And if you are saying that, okay, no, let's do one thing, in this segment also I will use same area, but here I will be using area 1, here I will be using area 2, then prefixes can move from one regular area to another regular area without having backbone area. And here already this MPLS VPN is working as super backbone, so you cannot have more than one backbone area. That's a problem now. How can we solve this problem? We cannot modify it. You have two solutions now. Either use PBR, policy based routing. But the problem is, even for R1 its best path, I mean P1 if you check routing table for VRF Yahoo, its best path to reach it is via 3.1 itself. Now what will you do by configuring PBR? Because for the routing table of P1 itself, its best path to reach all these prefixes is via OSPF domain. Because the AD value of IBGP is 200 and of OSPF is what? 110. And before metric it compares AD. Are you getting my point or not? Hello? See, P1 is receiving these prefixes via BGP as well as via OSPF. So to whom it is preferring? OSPF due to AD value. So now you can't configure PBR as well. For this purpose we are having sham link. sham, SHAM, sham link. It is something like virtual link. See, actually we can solve this problem by doing this configuration in such a manner so that either Yahoo CE1 should start to receive these prefixes via backdoor link as inter-area prefix, so that from both neighbors it will start to receive these prefixes as inter-area, and then after you can modify their cost to manipulate your path selection, or from both neighbors start receiving these prefixes as intra-area, then also it can compare their cost. Is not it? Now via backdoor you cannot receive these prefixes as inter-area, but with using sham link over MPLS domain we can start to receive these prefixes from MPLS domain, from MPLS VPN as type 1 LSA, as router LSA. So from there it will start to receive these prefixes as intra-area. Now from both neighbors it will receive these prefixes as intra-area, and now you can modify their host. Are you getting my point or not? Hello, are you okay with it? Fine. Now remember that sham link will be configured over MPLS domain between provider edge routers. For doing that, I'm going to configure sham link now over here on PE1. I'll create one loop back 100. I'll allocate its IP address as 100 on /32 itself. IP VRF forwarding is what? Yahoo. Put it in VRF Yahoo, and then advertise it into BGP so that PE2 will start to receive this prefix. Otherwise PE2 will not receive it, right? If you do not advertise it into BGP. So do one thing, router BGP 100 address family IPv4 VRF name was Yahoo, and then say network 100 then mask /32. Now there is a problem. If you are remembered that we have already redistributed BGP into OSPF, so this prefix will get redistributed. Tell me, this prefix will get redistributed from BGP back into OSPF now onto PE1 itself. Hello, you have already performed redistribution from BGP into OSPF for VRF Yahoo. So this prefix will be advertised into BGP and also will get redistributed into OSPF. Now PE2 will start to receive it via both two neighbors now. PE2 will start to receive it from PE1 via BGP, because BGP is IBGP, so its AD value will be 200, and also via OSPF, and via OSPF its AD value will be 110. So PE2 will start to prefer to reach this prefix via OSPF, and it should never happen. Because sham link will always configured over MPLS domain, right? So remember that in between those two IP addresses, the reachability of those IP addresses to whom you are going to use for configuring your sham link over MPLS domain, the best path to reach each other, those two IP addresses, must be over MPLS domain only. How can we achieve it now? I can configure conditional redistribution onto PE1. I can exclude this 100 before, from redistributing, during the redistribution from BGP into OSPF. Are you getting my point or not? See, I can use route map during redistribution onto PE1 itself. So move on PE1, then do one thing. Even you can check it out. See, you can move on PE2 and you can check show IP route VRF. Yeah, check on PE2. The best part to reach 100 is via OSPF. Check it out. See, it's not coming via BGP. So do one thing now onto PE1. Create one access list. 1 deny 100. then access list 1, route map, match IP address, router, check it out, router OSPF 100 VRF is what? Say redistribute BGP 100 and then we set subnets and then use your route map name. All remaining commands, all existing commands will remain there. I can show you. Do show run pipe6 and router OSPF. Check it out. For OSPF 100. See, previous command are still existing, but now you will see that this PE2 will stop to receive this prefix via OSPF. P2 have started to receive it via BGP. Are you getting my point or not? Have you understood it completely or not? Then after, move back on PE2 as well and create one loop back, like I created here. 200 IP address is 200, 200, 200, 200, 255, 255, 255, 255. IP VRF forwarding Yahoo, and then go to IP VRF, sorry, address family IPv4, VRF name is Yahoo. Say network, and same thing will also happen over here as well, because you have redistributed, you have already redistributed BGP into OSPF. So for PE1, the best part to reach 200, 200, 200, 200 will be via OSPF domain. So to solve this problem on PE2 as well, I have to say access list 1 deny 200, 200, 200, 200, and then 1 permit. This time I'll use route map like name of Cisco or CCIE. Permit, then match IP address is 1, router OSPF 100 VRF, tell me, say redistribute BGP 100, subnets VRF name is what? Sorry, subnets, and then route map name is CCIE. So now if you move on PE1, check reachability, show IP route VRF Yahoo for 200 is reachable via, fine, that's fine. Even you can also try to ping with that, or you can say trace route 200.200.200.200, sorry, trace route VRF Yahoo, and then it's going via MPLS. Understood? After doing this configuration on PE1, say router OSPF 100 and it was VRF, yeah, we are using here area 1 on to both sides. We are using area 1 sham link. It is asking for source, which is, see, in virtual link usually we were using router IDs, but here you are not using router IDs. For sham link you have to use dedicated addresses and they must be reachable to each other. And then it will ask for destination, which is, in same manner, move on to P2. Router OSPF 100 VRF is what? And then, sorry, it was 0. So fine, then you have to say area 1 sham link source destination. Now sham link will come up, same as virtual link. See, once this sham link will come up, see, sham link is also running as a demand circuit. You understand? And then after check show IP OSPF 100 database, you will find only and only router LSA. You will find only and only router LSA. See, and this LSA is coming via, see, I configured this router ID onto P2. Hello, and it's coming via sham link. That is why DNA bit is set onto it. And now after configuring this thing, move on Yahoo CE1 show IP route. Check its routing table. See, the best path to reach is via 3.2. You can see it now. Trace route 20. Because I already modified the cost of the interface of FA0/1 onto Yahoo CE1. That is why its best path is now via MPLS. Check it out. But if you move on CE2, Yahoo CE2, for it's still its best path is via backdoor link, because you have not modified its cost. You haven't modified its cost. So do one thing, move on FA0/1, say IP OSPF cost is like 100 or make it 1000. That's enough. Now for Yahoo CE2 also its best path will become via MPLS. See, 4.2. Hello, 4.2 trace route 20.1.1. See, check it out. So now for both sides their best path have become via MPLS, right? In case now if MPLS link goes down, like right now you can trace route it, even in source you can put your own loop back as well, but still you are going via MPLS. But in case if this FA0/0 goes down, if your MPLS link goes down, you will automatically start to go via, yes, see, via 12.2. Once it will come up, then you will see once again its best path will become via, tell me, yes, via MPLS. That's the thing. It's possible to configure in OSPF only this sham link. It's not possible in any other routing protocol. However, in other routing protocols there will not be any problem, something like this. Understood? For sure. This is how we can perform manipulation in MPLS. You understand? Shardeep, got it? Great. So that's the end of MPLS now. Only layer 2 VPN is left, and for layer 2 VPN it does not have anything to do. I'm having one video, you can watch it. I'm having video of it, layer 2 VPN, and you can watch that video and you can do that by yourself. Right? So MPLS is now done.